Okay, let's start. Just give me a minute, please. Okay, so in a Wittig reaction, an aldehyde, this is aldehyde group reacts with halogenoalkanes, form an alkene. The conversion shown in the following unbalanced equation. Compound H can be made from propanol. Okay, and the formula of the propanol is provided over here. Stage 3 in the reaction scheme is a Wittig reaction. Okay. So in stage 1, as we have used NaBH4, the reducing agent. So it means we are going to get okay, stage 2 red phosphorus and iodine. Okay. Stage 3 that is the Wittig reaction. This reacts with this and okay. So state the types of reaction that occur in stage 1 and stage 2. Stage 1, if you for is the reducing agent. So kindly mute, please. Whose mic is okay? So state the type of the reaction that occur in stage 1 and 2. So stage 1, when we talk about NaBH4 is used, so it's a reduction. If we look at in stage 2, no, we can't write reduction. It is actually substitution in stage 2. The reagents telling that okay, so it's a substitution reaction. Draw the structures of G and H in the boxes provided. Okay, So G is drawn its structure for the G. It is C2H5OH, right? And then on H, so on H, okay, we have to draw the H. So if you see over here, there is a double bond that is found between this carbon and this carbon, right? So I have to do this thing only. Okay, I have CH2 bonded to iodine, and here I have aldehyde. Okay, so in H, it can be C2H5, C. One minute, please. So, see over here, we have a C2H5 bonded to CH2 and it is bonded to iodine. And on the other hand, we have C2H5CHO. Okay, and if I draw the open structure, it would be like this: C double bond O and H. Okay. So if you compare this over here, that the oxygen O and the carbon with whom the iodine is bonded. So these two carbons, this one is actually this one, and this one is this over here. So a double bond is formed. So the same thing happen over here from this carbon and this carbon, that it can be C2H5 CH and so this is the reaction. Oh, sorry. This is the product H. So it should have okay. So here it is. And Is this clear? If anybody have any confusion to ask, we make this reaction reference as these two carbons are forming a double bond over here. So we can do this as well over here. Now let's move to the next part. Identify the organic products formed when compound J shown below is heated with concentrated acidified magnate 7. Okay, so heated with hot concentrated magnates 7. So in the presence of hot concentrated magnate, uh, so if you recall, from here the bond are broken down and we are left with these two structures. So if you see here the bond is broken from here and this carbon which have break the double bond have a so it would become a ketone because this is the carbon and the other carbon is this one. So here it's a ketone, then it means it is carboxylic acid. The carbon having a double bond on heating with hot concentrated magnate splits. So the one where the carbon having a double bond is bonded to one side chain, and now is this reaction is understandable to everyone? Now compound B is a liquid with fruity smell. See, we have that it's an ester. The reaction scheme shows how B can be made from C2H5OH. Reaction 1 is an oxidation reaction. Okay. Give the reagents and conditions required for the reaction 1. So the same thing that I have told you. Give the reagents and conditions required for reaction 1. So in reaction 1, it's an oxidation. So acidified okay. So acidified potassium And further the condition would be the other condition is heat under reflex. Okay. Now part 2. Construct an equation to represent reaction 1. Okay. So it would be CH2.
सर हम पोटेशियम डाइक्रोमेट भी यूज कर सकते हैं ना?
यस, पोटेशियम डाइक्रोमेट भी यूज कर सकते हैं, दोनों यूज हो सकते हैं। एटॉमिक ऑक्सीजन के लिए हम ये पुट करेंगे, then we would get 2 moles of carbon dioxide and 3 moles of water, right? Yes, is this equation is balanced or not? So I have to put 2 suggest the type of reaction that occur in reaction 2. So if you look at reaction 2, here it's a CH3 where it is substituted by CH2Br. So it's a substitution reaction. Next part, sulfuric acid acts as a homogeneous catalyst in reaction 3. Explain why H2SO4 is described as a homogeneous catalyst. As okay, if it's a homogeneous catalyst, so it means as it have a same state as. Is this clear?
सर जो आपने इक्वेशन लिखी है उसमें ऑक्सीजन बैलेंस है?
नहीं, उसमें oxygen 1 minute 4 and 3 7. Yeah, the oxygen is not balanced. Okay, so 7 oxygen are over there.
सर इस क्वेश्चन में जो है वो रिएक्शन को रिप्रेजेंट नहीं करना, इसमें तो फिर CH3CO2H बनेगा।
1 minute. 1 minute, please. Yeah, sorry. यहाँ पे that is wrong. This is wrong. 1 minute. Let me do this again. Construct an equation to represent reaction 1. Okay, if you look at reaction 1, it's an ethanol that is converting into ethanoic acid. So yes, it's an ethanoic acid we would form, not carbon dioxide. So C2H5OH on oxidation gives you CH3, COOH, and H2O. Now, if you balance the equation, yes, that's it. So this is the equation. Now, so this is the type of reaction that occur in reaction 2. In reaction 2, this CH3 is being substituted. The hydrogen CH3 is being substituted by CH2Br. So okay, so the reaction 2 is substitution. Now the homogeneous catalyst. When the state of catalyst and the reactants are same, then it is homogeneous catalysis. Okay, now part B. Reaction 2 needs to take place in the absence of water to prevent formation of compound C. Okay. If C, this is compound C, okay, it's present in the reaction mixture of reaction 3, okay. A different compounds, compound D, okay, and compound D has a two identical functional groups. The infrared spectrum of D shows strong absorption at 1100 cm and 1720, but no absorption at OH bond. Use the data booklet to identify the functional group present in D. So, okay, so have a look over here. Reaction 3, we are getting ester. Okay. So if you see the infrared spectrum, you would find at 1100, this peak is due to carbon oxygen single bond, and at 1720. This is due to C double bond O. So, okay. So we can say that it's an ester. Okay. And why I figure it out that it's an ester? Because there is no OH bond signal. So a CO bond. I think we would continue it in the next class. Sorry, but I think I can't able to continue any further. So we will do in the next class. Thank you.